Okay, here they told us to use the following substitution. So we will do just that. And we can also find du while we are at it. It would say 1 over 2 square root x plus 9 with a dx. But what we can do is we can isolate dx by multiplying both sides of this equation by this denominator. But again, we know that the square root of x plus 9 can be replaced by u. Now we can rewrite the original with some of these substitutions. So we have integral symbol. We have 1 over. Now, what can replace x? Well, notice that nowhere here do I have an x isolated. So let's quickly go back up here. So why don't I square both sides and then subtract the 9 away? Do so, and you'll see that u squared minus 9, that quantity equals x. So that's what I'll substitute back in here. So by substitution, this x, which is this, gets replaced by that down here. Now this here, that's just u. And then dx is 2u du. What's convenient here is that these u's happen to knock out, and I can take this constant of 2 and pull it out to the front. Now, as it turns out, this denominator can be factored because it is what we call a difference of squares. So now the predicament is a familiar one. We are actually going to hit this with partial fraction decomposition. So let me switch color pens here. So let's do some partial fraction decomposition with this here. We did this not too long ago. So I suppose I'll use this column here to show my work. And then recall how that from here, we essentially take this factor denominator and multiply every numerator by it. Things will simplify. So let me sort of kind of fast forward through that process. If you do just that, you'll get back the following. What we can do here is we can distribute the a's and then we can shuffle some pieces around. And what we can also do is on this side, we can introduce a 0u term. Because now what we can do is we can create a system of equations. Because here, that is the coefficient of u, but this is the coefficient of u, this is our constant, and this is our constant. So the system of equations that comes to life is the following. And now we are to solve this system by elimination or substitution, whichever method you'd like. What would we get back for a and b? Well, let's see. It turns out that a and b have these values here. And now that we have a and b, we can drop them back up here. And then these two fractions would be the decomposition of this original ratio here. So let's go back to this part here. But let's drag and drop a and b in for these values up there. So again, take note of what happened. This here is the same as this. These are identical. But this happens to equal these two fractions. That is why this here disappeared and these two fractions appeared here. With, of course, a and b having these particular values. So now let's go back up here and we can make we can rewrite a couple of things. But notice that really this is just a natural log. This is also a natural log. We have these coefficients in front of them and there's a 2 in front of all of that. So why don't we rewrite this with natural log? So let's take the actual antiderivative now. And while we're at it, why don't we distribute the 2 to both of these and reduce? So I distributed the 2 and I reduced with the 1/6, and then I took natural logs. So we have this here, but recall now that u is the square root of x plus 9. So make that substitution back into both of these. And then, as is often the case with calculus problems, the finished result can in fact be simplified a hair, but that's not really the emphasis. So this is one valid solution.